175 ends in 5, so we automatically know that it's divisible by 5. It also ends in a 75, so 175 sounds a lot like $1.75, which means we know it's divisible by 25. So either one, whatever you want to do. 25 times 7. If we had 7 quarters, we'd have $1.75. 25 isn't prime. 25 is 5 times 5. 7 is prime, just 1 times 7. 5 is prime, just 1 times 5, so we circle it. And we circle the second 5 as well. Now to write it in prime factorization, I have 5 times 5 times 7. So to simplify that, I have 5 squared times 7. 180 ends in 0, so we know it's divisible by 5 and 10. I'm going to use 10 times 18. It's even, so we could have divided it by 2 as well. It doesn't matter how you divide them, guys, as long as you use any set of factors. We could have used 36 and 5, 2 and 90. Okay. Here, 10 is 2 times 5. 18 is 2 times 9. Again, you could have also used 3 times 6. Doesn't matter what factors you use, as long as they multiply to that value. So 2 is prime, 5 is prime, 2 is prime, 9 is not. 9 is 3 times 3. 3 is prime, and 3 is prime. So I have 2 times 2 times 3 times 3 times 5, which if I simplify here, I have 2 squared times 3 squared times 5. And to figure out if your prime factorization is right, we just multiply it out. So you could type in your calculator 2 times 2 times 3 times 3 times 5. You should get 180, or you can take 2 squared times 3 squared times 5. You should get 180. So to figure out if your prime factorization is right, you just multiply it back, and you should get back to the number that you broke down. 420 is divisible by 10 because it ends in 10. So 10 times 42. 10 is not prime. We can break that down into 2 times 5. 2 times 5 gives me 10. 7 times 6 gives me 42. 2 is prime. 5 is prime. So both of those branches are done. 7 is prime. That branch is done. 6 is 2 times 3. So again, we keep going on our branches until we get prime values. 2 is prime, 3 is prime, and then we stop. So here, I have 2 times 2 times 3 times 5 times 7. 2 times 2 is 2 squared times 3 times 5 times 7. And that is my prime factorization. And because we could break all 3 of these down into their prime parts, they started off as composite numbers. So 420 is composite, 180 is composite, and 175 is composite. A monomial is a number, a variable, or the product of a number and one or more variables raised to whole number powers. Monomials have just multiplication. There's no adding or subtraction. So to factor a monomial, we write the monomial as the product of prime numbers and variables with the exponents of 1. So here we're going to factor our monomial. I'm going to take 28 and use my factor tree to break it down to its prime factors if I can. Here I can. 28 is 4 times 7. 4 is not prime. It's 2 times 2. 7 is prime, so we circle it. Here I get 2 times 2. So I can write in factored form, where I just list out all the factors. 2 times 2 times 7 is what 28 simplifies down to. Then I look at my variables. I have an x, so I multiply by an x. And then I have y cubed, which is the same as y times itself 3 times. So times y times y times y. Base times itself, exponent number of times. And there I have 28xy cubed in factored form. Here it says to factor the monomial. In 13, I take my number part 6, and if I can, I break it down. 2 times 3 is how I multiply to 6. Those are my factors. 2 is prime, and 3 is prime. So here, I get 2 times 3. Then I look at my variable parts. I have an a, and I have a b. So 2 times 3 times a times b. Give 14 a try. My number part is 15. My factors are 3 times 5. 3 is prime, and 5 is prime. So I have 3 times 5, and then I look at my variables. N cubed is the same as n times n times n. Base times itself, exponent number of times. So 3 times 5 times n times n times n. For 15, if we look, 3 is already prime. So now I can go right to my variables. X times itself 3 times. Then I take y times itself 3 times. Base times itself, exponent number of times. Factored form. 36s to the 4th t. Here to factor it, we take our number part, using our factor tree, find its prime factorization. So here I can use 6 times 6, 3 times 12, 2 times 18, lots of options, 4 times 9. Whichever one you want to use. 6 is 2 times 3, and 6 is 2 times 3. 2 is prime, 3 is prime, 2 is prime, 3 is prime. So my prime factorization of my variables is 2, or my numbers is 2 times 2 times 3 times 3. And because we want this in factored form, we're going to leave it. We're not going to switch it into exponential form because we want it in factored form. Then my variables, I have s times itself, exponent number of times, 4 times, and a t. And there we go. That's all I have for section 4.1.